All right, Chapter 9 review test is tomorrow. When a transformation is applied to a figure and then another one is applied to its image, that would be a composition. It's not order of symmetries, it's a composition of transformations. Oops, sorry, I didn't mean to cross it out, but whatever. If a figure is folded across a straight line and the halves match exactly, the fold is called the line of symmetry. I really think that it can be called a line of reflection as well, but line of symmetry is what we were looking for. A blank enlarges or reduces a figure proportionally. It would be which one of those two? Dilation. A glide reflection slides it and flips it. Choose the term again that best completes each sentence. The number of times a figure maps onto itself as it rotates from 0 to 360 is called the number of times is the order of symmetry. The size of the angle is called the magnitude. A blank is the same distance between each point of the figure and its image. Okay, when you do a reflection, all the points are an equal distance from the reflection line of symmetry, or the reflection line. So a line of reflection is the same distance from each point, not a translation vector. A figure has blank if it can be mapped onto itself by a rigid motion. It has symmetry. A glide reflection includes both a reflection and a translation. It's a slide and a flip. We're continuing with that concept of filling in the proper term. To rotate a point 90 or 180 counterclockwise, which is this rule? If you are going counterclockwise about the origin, you multiply the y coordinate by -1 and then interchange the x and y coordinates. That is a rotation of 90. Now, you have that in your ISN. Let me tell you why you should have known that one without looking it up. I'm hoping that you remember that 180, you switch the signs on both x and y. You don't switch their position. So if you remember 180 is the one where you just change the sign of x and y, then that had to be 90-degree rotation. The one that you change x, the sign of x, and then switch an x and y is when you rotate to 70. Okay? A blank is a congruence transformation. Well, what are the transformations? The transformations are reflection, rotation, translation, dilation, glide reflection. The only one of these is a transformation is a reflection. A vector is simply the directions you're given for a translation. The phone shouldn't be out. A figure has blank symmetry if the figure can be mapped onto itself by a rotation between 0 and 360. Is that plane symmetry or rotational symmetry? Well, it said rotation, my goodness. Rotational symmetry. All right, now it says to graph each figure and its image under the given reflection. All right, so we're going to go ahead and graph the points first to -4. Label it A. 4, -6. Label everything B. Labels count on the test. 7, -3 is C. And then I forgot earlier today about D. I just saw the 3 and I went and thought triangle. To make sure you continue reading, there is another point D at 5, -1. Okay, so we're going to obviously be making something four-sided. Go ahead and draw it. Looks like it's probably a rectangle. Then next, we're going to go ahead and say, well, what are we doing? We're going to reflect it in the x-axis. The x-axis is the horizontal axis. So I'm going over this line. Now, the way you would do that, if you wanted to describe for me, because on the test you may have to describe what you're going to do, you would be either measuring the distance from that each point is from the x-axis and going that same distance to the other side of the x-axis. So D is 1 below, so you pop straight up, 1 above, and write D prime. C is 3 below the x-axis, so go straight up from there, 3. The other way you could describe what you're doing is to change the sign of the y values. A is 1, 2, 3, 4 below, so count 1, 2, 3, 4 above, straight above it. And then B is 6 below, so go 6 above and label it B prime. Grab your ruler or straight edge and connect your points. Okay, that's the reflection in the x-axis. Anybody still need this? Okay, so next we're going to start plotting again. I'll go back and get a blue pen. All right, negative 1, 1 is left 1, up 1, label it x. Negative 1, negative 2, label it y. Left 1, down 2. V is at 3, negative 3, that's right 3, down 3. Draw the triangle that they would create. It says that we are to reflect in the y-axis this time, which is the vertical axis. So the way we do that is either change the sign of x, which you could write down your points if you were asked to. You would change the sign of the x's. It would be 1, 1 for x prime. Y prime would be 1, negative 2. So I'm suggesting that it's possible, but you maybe want asked to write down the points. You would change the sign of x, negative 3 for z prime. Otherwise, you would need to count how far you are from the y-axis and then go opposite side. So x prime is 1 away on the left, go 1 to the right. Y prime is the same. And z is 3 to the right of the x-axis. We should go, of the y-axis. We should go 3 to the left. And that should be the point negative 3, and it is. It matches our points 1, 1, 1, negative 2, etc. Connect your points and draw your triangle. They're going to overlap the original triangle. Anybody need this page still? I can wait. Okay, 13, start plotting your points again. Hopefully you're plotting correctly. 0, negative 1 is do not go right or left, go down 1, so you're right on the y-axis. So this is where A is. And 2, 0 is on the x-axis, so B is here. C is at 3, negative 3. Excuse me, I have a tickle in my throat. I'm going to draw my little triangle. Okay, and then it says to translate it, or no, it says graph under the given reflection. This is not a reflection. This says to do the vector negative 5, 4. What does that mean? Okay, so move your points left 5 and up 4. So you do all that at once. We're going to go 1, 2, 3, 4, 5, and up 1, 2, 3, 4. Now I want to show you something, because I could have this be a question where you're not even graphing. What you can do is subtract 5, and add 4 to each of the coordinates. Okay, so I'll show you how we can know. If I asked you this without a graph, you would do 0 plus negative 5, and you would get negative 5, and 4 plus negative 1, or negative 1 plus 4 is 3. So we should be at negative 5, 3, and we are. Okay? You are, but simply if you have the graph, you go ahead and just slide them around. 1, 2, 3, 4, 5, 1, 2, 3, 4. So I just translated that vector negative 5, 4. 1, 2, 3, 4, 5, 1, 2, 3, 4, and there should be your C prime, which would result the same thing. C prime would be at 3 minus 5 is negative 2. Negative 3 plus 4 is 1. Let's see, are we at negative 2, 1? Yes, we are. All right, so I just want you to remember that you can add or the vector values to the points and find the new coordinates. All right, so there's that triangle. Number 14, I'm going to switch over to my document camera to show you how to do that. All right, so this thing is low on memory. Let's hope I don't lose anything. You need to have rulers to do this. Get some of my stuff out of the way. All right, my computer was not cooperating with me using the document camera, so I'm going to have to go ahead and just tell you what to do. So let's, as a description, you would put 0 on your ruler here. Okay, and then you want to measure the length of that vector, and it comes out to 3.5 centimeters. Okay, that's what I got when I measured it. Would you agree with that? You put 0 here of your ruler, measure down to the tip. It's about 3.5 centimeters. Okay, so what you do then is you slide over. Okay, and you go the same distance straight down from each corner. Okay, so you're going to come straight down that distance from every corner. You can draw the little lines even. I believe I have to kind of extend my page also to get it to look right. You're measuring from every little spot 3.5 centimeters. Once you do that, Bryce, did you have a question? Okay. You're then going to connect to each spot, and it should come out to be that shape. And it'll look something like this. Actually, I didn't go quite far enough down on my segments in the front. I'm going to get rid of that. I think I need to stretch these a little. Mine aren't quite long enough. But it should look exactly the same shape as your original figure. Okay, yours look more like that, I hope. Okay. All right, so you have to come that vector, so we went straight down the same direction as the vector, the same length as the vector. All right, that's what you do for doing a translation along a given vector. All right, now 15, let's move on to that one. We're going to plot -2, left 2, up 2. -2, 2 is M. 0, -2 will be on the y-axis. There's N. And 1, 0 on the x-axis for O. Connect them. Okay, now it says to do 180-degree rotation. So you look up the rule for 180-degree rotation if you didn't remember it. And it's going to look like this. It's going to say X and Y, and then it has an arrow goes to negative X, negative Y, which means change the sign of X and Y. Okay, so what we do is we say, all right then, M prime, if I can make an M, will then be at -2, sorry, not -2, it'll change to +2, excuse me. It's going to be, M prime would be at 2, -2, N prime would be at 0, +2, and O prime would be at -1, 0. Can't change the sign of 0. So 2, -2, our new point, M prime. 0, 2 will be up here, N prime. And -1, 0, O prime. And then draw out the triangle. Okay. Does anybody still need that? Yes. Okay, I'll wait. All right. 16, I got 3 points to plot again to get started. 1, 2 for D. Oh, I think that's going to be in the way. So I'm going to put D here, 2, +3, wait, G, and 1, 3, F. I got a little bitty triangle. And it says to rotate it about the origin 90 degrees. The rule for rotating 90 looks like this. It says take your points X and Y and do -YX, doesn't it? Okay, which means you're going to change the sign of Y and switch X and Y. All right, so D prime will be at -2, 1. G prime should go to -3, 2. And F prime, I'm changing the sign of Y to -3 and switching it, -3, 1. G prime, -3, 2. G prime, and then -3, 1. Oh my gosh, I've got to move that letter. -3, 1 is F prime, and that was D prime. So now this is where the triangle is. And just to illustrate why that is actually the right move, if you connected D to the origin and D prime to the origin and D to the origin, you see how this is a right angle right there? That would mean counterclockwise. All right. Anyway, that last little segment I forgot was going to be straight. Okay, to the next one. 17. Draw all lines of symmetry or write none. Bless you. We're all sneezies. All right, we're going to cut this arrow in half. Which way can I do it? Can I do it more than one way? Okay, I saw some hand movements telling me to go like this. All right, horizontal cut. This just has one line of symmetry. All right, what about the next one, though? How many is it going to have? 6. Let's see. So we're going to draw them. It's going to look like more than 6. Okay, but here we go. I'm going to go through that corner, through the middle, to the other side. Go through each of the corners through the opposite corner, opposite vertex, if you will. That's 3 of them. But what other way can I go? Straight down the middle, okay. And then in the middle of this. Okay, and then the middle of that one. So now I did 3 more, and now it looks like there's a bunch of them, but it's only 6. And number 19, we're going to write none. Yep, there aren't any. Now this has the side of the figure has plane symmetry, which means we could cut it with a plane. Axis symmetry, which means you could spin it on a line. And both or neither. All right, this thing I could spin around, right? Just like a roll of toilet paper. All right, so it definitely has axis. Can you cut it in half with a flat surface? Okay, we could slice her that way, or you could cut through the top any direction because it's circular. So this has both. This square we could spin around on an axis right through the center, and every 90 degrees it would land on top of itself. We could also cut it in half, so it does have both plane symmetry and axis symmetry as well. Now, what about this thing? I know it's very hard to see. I heard it's very, very pale on your worksheet. It's supposed to be a pyramid, okay? And it's got a rectangular base. So can you spin it without having to go 360? Yep, you sure can, because you can do a half turn, right? And it would spin on its axis 180 degrees and map onto itself. So it's got axis symmetry. Can you chop it in half? What can you do it this way? No, you could go like cut it in half that way, and it would be the same on both sides. It does have both. Lots of things have both axis and plane symmetry that are three-dimensional. Huh? Okay, does this thing have rotational symmetry? Well, it better, because what's it look like? A ceiling fan. You have a lot of symmetry in your houses. You should look around sometime and look at it in your home. There's tons of symmetry all over the place. This thing rotates, and it has how many blades? So that means it's order 4. Okay, so you say, yes, it has rotational symmetry. The order is 4, and so the magnitude would be 360 divided by 4, or 90, which is 90 degrees. Number 24, anything happen in there? Okay, no. Abstract. No symmetries. Okay, what kind of transformation is this on number 25? You're going to have a question to say, what kind of transformation is that? It's a dilation. And then it's saying, what is the scale factor? How do you know? What'd you say? Did somebody already find it? What'd you say, Cadence? 3. How did you figure that out? You picked 2 points? Perfect. That is exactly what you should do. It doesn't matter which pair of points you pick, but you want to look at A and compare it to A prime, all right, or vice versa. So which one's the new figure? The one with the little slashes on it, the prime notation. So let's see where that is. It's at 3, 3. The original point, now that's your new point, and your old point was at 1, 1. Okay, so he figured out, and he is correct, that the scale factor is 3. Why not 1/3? This was not what has been done to the original figure. Was it reduced or enlarged? Yeah, it was enlarged, right? Okay, so pay attention to that on the test. Hint, 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 very important. It doesn't always get enlarged. Sometimes it shrinks, okay? So if the new one has a point of 3, 3 and the old one has a point of 1, 1, what did you do to the old point to get the new point? You multiplied by 3. And so what you do is you're comparing new to old, no matter what the numbers are. 3 over 1 gives us 3. So the scale factor is 3. But look at this next one. What happened? Would you guys need me to stay back there a second? Okay, I'm moving on. All right. This one is a weird scale factor. We've got the new is down here and the old is up there. So that means this was a reduction, right? It's a reduction. So that means our scale factor should be a fraction. So what we're going to do is compare the new number, which is the 6.75, and we're comparing that to the old distance, which is 15. All right, and you're going to need to use your calculator. If you type 6.75 divided by 15, you're going to get 0.45. All right, now, I might not have that as an option. What if I want a fraction? How does your calculator fix that for you? Remember the buttons? Math, enter, enter, okay? So because my computer's running so slow right now, I don't think I can even use the calculator. Yeah, it's not even happening. Okay, so it will tell you that this converts to 9 over 20, 9/20. I know how to do that. That's 45/100, and then you divide by 5, and that's how you get 9/20. That's the way to do it manually. All right, members of the math club just use your calculator though. Members of the math club use an overhead projector to make a poster. If the original image was 6 inches wide, this will be the old one then, and the image of the poster is 4 feet, that's going to be the new. What's the scale factor? Scale factor is always new over old. So we got to figure out 4 feet compared to 6 inches. Wait a minute. How can you do that? They're not the same units. I need to fix that. So what would 4 feet be in inches? 4 times, there are 12 inches per foot. So we've got 48 over 6, and that 48 divided by 6 would be 8. Okay, so the scale factor is 8. Okay, you're with me? Yep, scale factor is 8. You can't do 4 feet to 6 inches. You must convert, right, to the same units. All right. Okay, point N has coordinates 4, -3. What will the coordinate of the image be if it reflects across the y-axis? You will have some questions where all you have to do is tell what the new point would be. If you go over the y-axis, you can just think about it like this. 4, -3 would be somewhere around there. If you went over the y-axis, it's going to go over here. So what changes is the sign of x changes. All right, so the new point would be -4, -3. The answer is -4, -3. 29 says, what's the angle of rotation that maps T onto T prime in the figure below? Now, I need to let you know that the answer in the key is incorrect. The answer in the key on the last pages is incorrect because it gives a rotation of clockwise. What way are we supposed to go? We said all of them are going to go counterclockwise. So this would be 1 turn, 2 turns, 3 turns, 4 turns, and 5 turns. I forgot to fix that answer before I printed them off. I have since corrected that. So I wanted to let you know that we need to do a 5 turn to get to T prime. Now, first thing we got to figure out though is what's the angle measurement for one of those turns. Okay, so we figure out the order. What's the order of this thing? 1, 2, 3, 4, 5, 6, 7, 8. Isn't it 8 all the way? Yeah, 8 turns around the whole thing, right? Order 8. So the magnitude of one turn, is 360 divided by 8, which is 45 degrees. Okay, so that means that every angle of rotation is 45. How many 45s are we going? We're going all the way from there to there to here. Another one, and that's why I'm telling you, you don't have to draw all this to understand it, but I'm trying to illustrate for you why it's going to be 5 times 45, and that's 225-degree rotation to get from T to T prime. Now, in the key, it says 135. Do you see what the person that did the key made that error was going clockwise 1, 2, 3 turns, and 3 times 45 is 135 degrees. All right, so that was what they did. They went clockwise instead of counterclockwise, as we said all the rotations should be unless otherwise specified. Okay? So our correct answer is 225 degrees. Number 30. Which of the following is a side length in an isosceles triangle DEF? This is kind of an off question being in this unit because we're going to be doing this stuff starting up the day after tomorrow because we're going to be talking about isosceles triangles. But we can do this. We would set these two segments equal. So we'll have, excuse me, I don't know what that. Okay, I'm having a little problem. Hold on. Okay, so number 30 says which side? I know we started this, but everything shut down, so I'm kind of just fixing it. Which of the following is a length in an isosceles triangle? This side and this side are marked congruent by the slashes, so we can solve for x by doing 10x equals 8.5x plus 3. We would then subtract 8.5x from both sides, and that would give us 1.5x equals 3. And then we could divide by 1.5. And 3 divided by 1.5 gives us an x value of 2. Now, what's a common mistake to do is circle A. Okay, but that's not what they asked. They said, which of the following is the side length in that triangle? So if I substitute 2 back in right here, I'm going to get 20, right? If I substitute 2 back in over here, I'm going to get 20. So it's not either of those sides because that's not one of the choices. If I substitute 2 back in here, 3.5 times 2 plus 4, I get 3.5 times 2 is 7. 7 plus 4 is 11. So it would have been choice D. Okay? I don't know if we went over that. Anyway. Number 31, it says, given that A is parallel to B, I'm going to highlight that. A parallel to B, those are the lines that are parallel. And then they're calling the line T the transversal. Oops, that wasn't a very good line. Oh, nice that it snapped back for me. It says, what statement below justifies the conclusion that angle 1 would be congruent to angle 2, that those are equal? What kind of angles would 1 and 2 be? Corresponding, yep. So it would be that corresponding angles are congruent if the lines are parallel. Okay, let's see. Does this figure have rotational symmetry? Well, it sure should, because otherwise fans would not be working in our houses, right? Because that looks like a fan. All right, so and they spin. So this is a yes, okay. The order is what? 4, okay, order 4. You just count up the blades. And then the magnitude would be, oops, that's a weird G. 360 divided by 4. We've done this one repeatedly, which is 90 degrees. 33, Regina left her office downtown and traveled 3 blocks west, which would be going to the left, and 5 blocks north, which would then be going up. Write a translation vector to describe her route. A vector is in this kind of notation, where those pointy brackets. So what that left would be going left, like, and what's that when you're doing x values? If you go left, you're going negative, okay, to the left is negative. So that'd be -3. And then if you're going up, that would be +5. Okay. Excuse me. 34 says dilate the figure shown on the coordinate grid by a scale factor of 1.5 centered at the origin. So it's going to blow out from the origin It should stretch that direction. Okay. What I need to know, though, is what these points, where these points are. So I'm going to jot down the coordinates of the points. So D is located at 1, 2. You always write your X component first, your Y second, 1, 2. E is located at 4, 6. And the point F is right now at 6, 2. Okay, it said to dilate a scale factor of 1.5, which means we're going to multiply the X and the Y values by 1.5. That'll give us D prime, E prime, and F prime. So I'm going to jot down the names of those points. If I multiply 1 by 1.5, I get 1.5. If I multiply 2 by 1.5, I get 3. So that would be D prime. E prime is going to be 1.5 times 4, which is 6. And 1.5 times 6, which happens to be 9. Now, you, of course, can do on your calculator. And then 1.5 times 6, we got 9 again. And 1.5 times 2 is going to give me 3. Okay, so these are the points I need to plot. 1.5, 3. It's going to be right there. Did you already have these done? Yeah. And 6, 9, E prime. Oh, what a weird E. Okay, and F is at 9, 3. That's F prime. Connect them to make the triangle. All right, that's the dilation of that figure by 1.5. 35 is asking us what the vector is. So you want to look at the new figure and then go find out where you went to go from the old figure to the new figure. How'd you get there? So it says what translation. So that's going to be a vector, which will be in this notation. So all you got to do is count. How did you move to get there? So to go from A to A prime, you'd have to go over how many? 1, 2, 3, 4, 5, 6, 7. Yep. And down 3. So right 7 is 7, positive 7, and down 3 would be negative 3. 36 says name all the rigid motions and explain why they are rigid motions. Okay, the rigid motions were reflection. That was the first one we did. Translation, which was the second type of that we did. Second type of transformation that's a rigid motion. Rotation is also a rigid motion. And then we did glide reflection, which we didn't really cover heavily, but we did do it. Or composition of one of those, any of those reflections. Those are all rigid motions, and that's because C-A-U-S, excuse me, because they the image and pre-image are congruent. Now that's one way to say it. Another way to say it would be that why are they congruent? They're all the angles and lengths stay the same. Now, the one that isn't a rigid motion transformation was the dilation, because it changes size. All right, so all of those preserve our rigid motion transformations. Okay. 37, a picture is 5 inches by 8 inches. It's going to be enlarged to 3.5 times to make a poster. What are the dimensions of the poster? So all you have to do is take your dimensions and multiply them by 3.5. So do 3.5 times 5 and 3.5 times 8. That's 17.5 inches. And 8 times that would be 24 plus 28 inches. So it'll be 17.5 inches by 28 inches. That's the answer. Okay, 38, explain how you would reflect an image over the y-axis. Okay, one way is to look at your rule, which would be if you're going over the y-axis, then the x values change sign. So change the sign of the x values and plot the points. Now, there's another way you could describe it. Or you could say count how far the point is from the y-axis, excuse me, and go the same distance to the other side. Okay, to the other side of the y-axis. Okay, so you got to go straight across from there, right? All right, so I don't care which way you describe it, as long as you say, I found how far the point was from the y-axis, and I went that same distance straight across to the other side. And you don't have to have both of those explanations. Okay, just one or the other is fine. All right, then 39, name the image of S under a reflection in line N. Okay, I don't know why we missed this so much. First of all, you should find line N. Okay, highlight line N. Now, it's not going to be the same question on the test. It might be something else on here, and it might be over line M. But you got to know what line you're going over. So if we name the image of S, okay, there's S, and if it goes over line N, where's it going to go? To T. It's got to go straight across the same distance. So this distance is equal to that distance, okay? So that's why it goes to T. And so the answer to the question is point T. Okay, so let me just, I don't know, for the test, what if I just said, what is the image of T, point T, under a reflection in line SV? Now, I'm making up a problem real quick. So like here, what if you were going over, oopsie, that's horrible. All right, that line. So nice that it's straightened out for me. Now, I'm making it up, and I'm not saying this is what's on the test. I'm just saying it could be a question. It's a legitimate question. Where would T have gone if it went over that line? It has to go directly over it at a right angle. So it'd be at W. Okay? Yep, whatever line you're going over, you want to, now, let's say we went over, and I'll just do a last one. What if we went over line M? Oops. So if I said, what's a reflection of S over line M, then that's going to go straight across to W. Or T will go straight across to V. Right? You got to pay attention to which line you're reflecting over. Say, wait, let me get the answer to the question that was actually here back. Yes, go ahead. Huh? No, it would never go to V, because if you're going over line M, you have to go at a right angle when you reflect. So it's the only shortest way across. You can't just go that way. If you went that way, then you were taking S over this line. If S went to V, it went over line TW. Okay? If you could even say, what is segment SX going over line TW. That would be, S would go to here, and X would stay where it is. It would be XV. If the whole segment went flying over that, would just flip over, it would be XV. Okay. So anyway, you just think about where, what, so you can do segments, you can do points, etc. All right, that's enough of that. Okay, now if you were to rotate, or wait a minute, you're going to reflect this figure over both line and U and V. What you pay attention to is what's the angle between the lines you're going over. So if you were going to take this figure and you're going to flap it over this figure, and then you're going to flap it over that line, you're going to create a rotation. Okay, it's going to give you a rotation, and it will be twice the angle between the lines. We had that in our ISN. It'll be 2 times 98 degrees. So that's going to be 196 degrees. A rotation of 196 degrees is what would result from doing a reflection first over line U and then over line V. Oh, so the kind of transformation, I forgot about these little spaces, was a rotation, and the magnitude 196. And then B, if a figure is reflected twice over parallel lines, so the first reflection, you don't have to draw these, but it would do something like that. And then you would flap it over again, and it would turn back the other way, okay? What happened is you would get a translation, okay? So the transformation that results, boy, those are sloppy drawings, is a translation, and it is in your ISN. And how far is it? Well, it would have gone twice the distance between the lines. So it would have been 2 times 3, which would be 6 inches. So going from that first figure to the last one would be 6 inches of a slide or translation. Okay, and then this answer section, I asked you to change the answer on number 29 was not 135 because they went clockwise when we were told that all of our transformations would be counterclockwise, or rotations, excuse me, would be counterclockwise. So it should have been 225 degrees. All right, good luck on Chapter 9 tests.